Channel. Shall continue with our technical coding interview. So the question we have is jewels and stones. So you are given strings, jewels representing the types of stones that are jewels or jewels, and stones representing the stones you have. Each character in stones is a type of stone you have. You want to know how many of the stones you have are also jewels. Letters are case sensitive, so A is considered a different type of stone from A. So example, you have input, jewels, stone, 3. So how does that sound? So you are given strings, jewels, representing the types of stones that are jewels, okay? And stones representing the stones you have, okay? Each character in stone is a type of stone you have, okay? So I have A, B, B. You want to know how many of the stones you have, okay? Many of the stones you have are also jewels, okay? For instance, so if you take this A, how many A's are here? 1. Take this capital A, okay, 2, okay? That means take this Z, okay, that makes sense. So the length minimum of 1 for both and maximum of 50, only English character. All characters of jewels are unique. Okay, so there can't be duplicate here. Can only expect duplicate here. Well, I think that's pretty straightforward. What we're going to do is we take each character in jewels and slide it over the stones, and if there's a match, we have a counter, we increment it by 1, and we take the other two, we slide it over, there's a match, we continue incrementing by 1. Does that make sense? So that's going to give us a quadratic time complexity, which is going to be length of jewels multiplied by length of stones. Can we do any better? To do better, what we can do is we can do it in linear time. So what we do, but that will require extra space. So what we do is that we go through the stones once, we create a dictionary, and we create the number of count of stones. Then we now go through the jewels only once, and what we do is we also have a counter. So once you encounter a character, we'll retrieve that character from the dictionary and update our count like that, and that will be linear space. Okay, let's go with the linear space, but that will going to give us that will be linear time, sorry, but the space the space complexity will be linear space, because we will have to store the stones and the length of the stones. All right, so let's go with that. So what we do, so we say a dict of stones, so we have that as dict. Then we have a dictionary that will say for stone in stones. So what we do is that if dict underscore stone dot get stone. So if this one gives us a none, I normally like to do the else part first. So if that gives us a none, so the else part we execute. So what we do is that means it doesn't exist, we create it. So stone, and we have a counter of equals to 1. But if it does exist, that means we just increment this one. So that means we already have it. So we just increment by 1. Okay, so we have that. So the next thing we now do is that we increment our result, which is how many of the stones you are also Java. So the counter that we're going to return, that will be 0, and at the end we return that counter. So what we now do is that we go through the jewels. So we say for jewel in jewels, so we retrieve each of the jewel from the dictionary, but we need to check if it is there. So we check if dict underscore stones dot get jewel. If it is there, that means if this returns something, then we increment our counter by 1. We not by 1, by the value that is there. So we increment our counter by the value of that we stored initially. So this will give us the value. Okay, but if it is not there, we are not doing anything. We just keep that. So since it's not there, I think that's pretty all that we need to do. So let's run through example and let's see what we have. So here, by the time we go through our dictionary, so I just want to make things fast. We've done many tutorials on dictionary, so it should be obvious to us now. So our dictionary, we're going to have A to be a count of just 1. Then we will have capital A to be a count of how many? 2. Then we'll have small letter b to be a count of how many? That is 4. Alright, so by the time we finish this is what we're going to have as a result. So if we get this one, we increment it by 1. If it is not there, we start initialize it with 1. So here, by the time we now come in here, we pick the first A, letter A. So if it is there, because it is there, so our counter is going to become counter, which is 0 plus, so dict stones of A, that will be 1. So our counter will be 1 here. So by the time we go back and we pick capital letter A, we check, it's going to be 2, and we add 2 to this one, it's going to be 3. So that will be correct. So let's see the other example since we still have time. So if we go through this, so our dictionary this time around is going to be only Z. So we'll have capital Z, which has just 2. Okay, then that is all for this. So we come in here, we pick our jewels, which is small letter Z. So if it is there, so it's not there, so our counter will just remain 0. I think that looks good, so we can run it now. Good, that works. So let's see the other one. That works too. So let's submit. Okay. All right, thank you very much and see you in the next one.